Uh, Hi, everyone. New all Crypt Bytes Tech. We would be covering today interesting topic on blockchain, which is basically for either new to blockchain or would like to understand aspect about blockchain. The title is Understanding Blockchain. Here, your host for tonight, Priyabrat Dash, who I'm also a blogger for the Crypt Tech, and I also have with me Shyam, who is and also an evangelist, and he Sham, are you there? Can you just maybe give a little bit more introduction about yourself?
Yeah, hi guys. So this is Shyam here. So I'm joining in this webinar with Priyabrat Dash. So yeah, I am an emerging technology evangelist, and blockchain is one of the areas which is very exciting for me. Build some use cases and some applications for a very early stage proof of concepts on blockchain. So I'll be sharing some of my experiences and some of the use cases of blockchain once Dash goes through the initial round of the introductory content around it. So we'll touch base soon on this. Yeah, Dash, you can continue actually.
Thanks, Sham. So, agenda for today's session would be first I'll be the basics blockchain. Then we also two blockchain platforms, and then I would touching which is a private blockchain platform supported by Linux Foundation, and then finally we would also touch upon the future of blockchain and how some of the use cases, and that is where Sham would come in and would be talking about some of the use cases he has been working on. So let's get started. Okay, so I will start with this image to explain you how it works. So this image talks about blockchain transaction. You have two people, um, let's say A and B, and they are part of a blockchain network. Let's say, for example, Bitcoin. You have working for them a public key and a private key. Use sign the transactions and also public key across to the blockchain network. Once the transaction is digitally signed, there is a intermediary who would validate if that transaction is correct. That is to prevent any double spending. Traditional financial system, how it works? It works two parties doing a transaction. The transaction, the sender sends a transaction to a central authority. In let's say in case of credit card payments, it is Visa, who along with bank intermediary verifies the transaction and then confirms it, and then the counterparty receives the or the transaction completes where some goods are sent, and also a payment is made. But in case of blockchain, having a trusted intermediary, a group of nodes which would either verify the transaction, sent, and also a payment is made. But in case of blockchain, trusted intermediary of nodes would either verify the payment is made. But in case of blockchain, of nodes so I'll go back to the can you see my okay, fine. As you can see, so at this state, there would be they will add it to a block, and that's how a blockchain on those nodes in their respective the blockchain is saved in the respective nodes. Idea about how a transaction works. So in case of public key cryptography, what you have a public key and a private key. Private key is what you save yourself. Public key is what you share with others, and that is what you using public key. What you have, you and that particular transaction would where to be verified, and then in future we may also of what is a blockchain network. A blockchain is basically a set of okay, which flow from another node. All of a cryptographic computational to verify the transaction, and through that they will add it, which I explained in my first slide. Calculation. The blocks are then circulated across all the nodes across the saved in them. So now the question arises: how do you submit a transaction? You can use any of these nodes, participating nodes within a blockchain platform, transaction. So what you would need a private key, a address which is your public key, and that address is what shared between other parties. Have your own address and your own private key. Whole complex ending of the transaction into the blockchain will happen, and that would go across to other net. So next time, whenever the person B connects to this network and sees his public key, that is his address, he would definitely transaction is happening. Okay. How this particular verified transaction are passed blocks. Okay. And just to add upon, in case and in Bitcoin network, they are presenting mempool. How a tradition would look like. Let's say a block would have a header which will contain how to identify that block, keep the total number of transactions, then would be the block content. In announce or any other information. Input and an output. Input can be a hash to the, and output can be either a hash or a pointer to the next transaction. So simplest, if you look at it, makes this whole data structure of blockchain simple to understand. Okay, so now we will about public uh, in any kind of blockchain, they would say private blockchain, a consortia of companies working together to create a blockchain network, and then you obviously know like Bitcoin and Ethereum, which are public blockchain. So just to explain you in a public blockchain network of nodes that forms the blockchain network, a consensus mechanism to verify either through proof of work or proof of stake or some other mechanism. Would there would be certain economics involved or economics. So for example, if a miner in a Bitcoin network verifies a transaction, he would not only would get certain transaction fee for verifying that, but also would be in the mining process or verification of the block process would be creating a new Bitcoin. In effect, these incentives is how the whole public blockchain is secured. Like particular blockchain network can join the network and leave the network, in which you can access these blockchain networks, your wallets, which are the public keys, and you would definitely have your private key to sign a transaction or whatever amount either has been credited or deducted from your transaction. And what is good? In these public blockchains, you have a concept of block explorer. What this block explorer does is help you to search all the transactions that are on the blockchain and helps you to verify any kind of specific that you may have made to somebody else or somebody else have done to you, or any other transaction that have come across ever. Then we have consortia blockchain. Here, a group or a site to host certain nodes, and how they will verify this particular they would decide if the particular transaction or not. In case the particular transaction but in case that is not there, then they would either reject the transaction or it would be unconfirmed. Again, these kind of public semi-private blockchains not be allowed for writing by the public, but they may have an access or an API access to view the transactions partially. Again, an example of it can be Corda or even where specific nodes or terminals to access those kind of blockchains. And then by either membership service or some kind of clearing who manages that platform. It is possible that such a private blockchain to public or may not be required at all. So such a kind of private blockchain can be considered as it can be useful for database management,
Hey
audit,
Dash,
or
just to interrupt you, I guess your screen is not being shared anymore.
1 second. And this happened just now or sometime
Yeah, it
back?
just happened just now, I think.
All right. Okay. Is it now visible?
Yeah, it's good now. It's good. Yeah, you can carry on.
Yeah. Okay, cool. Uh, just let me just take a break and just check out if okay. Okay. Okay, I think some issue with the audio and video.
Yeah, the audio was breaking intermittently, but right now it seems to be okay.
All right. All right. Um, at least let me see if it is. Let me just share it again. Okay. So now out.
No, you're not. You're not sharing it anymore. Oh yeah, yeah, now you can see that.
Yeah. Oh, is the Okay, fine. I will just start from the public and private key part. Let's see.
Yeah, okay.
Okay, I think just to add upon the fully private blockchain, an example would be something like your Hyperledger, which is a good example of a private blockchain. Just a minute. I would continue after this. Just hold a minute. Okay. Let me restart the session. Can you see the screen, Sham?
Yeah, I can see your
Yeah, I
YouTube
can see your
screen.
YouTube screen. Oh, I'm sorry. Okay. Okay. Can you see that screen now?
Yes.
All right.
But maybe you can make it full screen.
Okay.
Yeah,
So
that's good.
the final. So now I'll move on to the rest of the um, part of the presentation. Okay. So yeah, a traditional blockchain application stack. How would it usually look like? Like uh, like a set of applications that would access through an API, probably a wallet API or an API provided by the blockchain platform. And then you would have the decentralized protocol or the blockchain protocol, which runs on the blockchain network. Now, here you would see that there is a overlay network mentioned. This overlay network may be a case in case of, for example, you want to be anonymous. In that case, you can think of Tor as an overlay network to bring more anonymity to your access to the blockchain, the Bitcoin blockchain. But generally, Bitcoin can itself be an overlay network to access all the services or all the features of the blockchain. Example of such stacks that are already developed on Bitcoin are example OmniLayer or RSK or colored coins. More of it probably I can take in future sessions. But yeah, the similar parallels, if you see in Ethereum, much of it is present within the Ethereum stack. And in case of Hyperledger, as we will see later, they have their own stack, which is similar to this. Okay, now coming to Bitcoin. So to just to give an idea how a Bitcoin looks like. So here you have, let's say, what you call a set of 3 blocks. And so the idea is that you have, if you, just to probably go and explain you to the, explaining a typical hash. So what would a typical Bitcoin block would have is typically a hash to previous transaction, and probably a transaction would typically would have a hash to previous transaction, the public key of the next owner, and also probably any amount that is to be exchanged. That would be a typical transaction that would look like. And that would be a block. A block would contain the previous hash, a nonce, and probably all the transactions present in the Merkle tree. Now, Merkle tree is the unique part that helps or that is used by miners to mine a transaction. And to add to that, Merkle tree is what usually the whole computation power takes like. And this is an example of a Merkle tree where various transactions would be chained into that tree. And it's possible that a Merkle tree can have all the transaction references or the hash to that. And the timestamping is what once a block is confirmed is added. Okay, now the tricky part. It's possible that multiple since Bitcoin or a Bitcoin blockchain is a decentralized network. It's possible that multiple miners can add a transaction to a block. Then what other nodes in the network would do? Will they accept all the blocks that comes, or will they have to do some sequencing? That's the unique part about the what happens is that blocks which are verified eventually across network, and whichever nodes get whichever block would add it to its and then when, let's say, another block is mined and is circulated across the network, that would have the hash to the previous valid chain, and based on that, we can say that the longest possible chain of blocks would be verified as the correct chain, and the other chain of blocks that is present within the node would be rejected. And that is how typically a Bitcoin blockchain across nodes works. Okay, now let me go to the public and private key. How basically a typical any kind of a Bitcoin or even other altcoins, a typical public and private key works like. So in case of any kind of cryptocurrency, a public key is the address of the wallet that through which you would access your fund information in the blockchain. And the private key is what you use to either encrypt or decrypt your transaction. And here is an example how it would look like. You have a transaction, for example, either send or get some kind of balance. Okay, so what you do is you encrypt it. You would have a public key and private key. With the private key, you basically decrypt that information, and then you can read or you can write. And this is the whole process that effectively would come in the overall any kind of digital signature that you would be doing on the blockchain. But the interesting part is that in case of adding a transaction or sending a transaction, you basically are not are not just trying to encrypt a message, but basically you are decrypting the reference to the previous transaction you have made, and you are sending that. And whenever any miner verifies a transaction or any node verifies a transaction, they're effectively verifying all the transactions that were ever made to come to the final calculation. Okay, so I will just quickly come to the blockchain use case, but before that, I will just check on the chat if there are any issues, and then after that, I will proceed. Okay, so the PPT link and also The other supporting links will be present along with the video. And the video is also recorded. Okay, so let me now go back to the from where I left. Okay, can you guys see my screen? I can see that. All right.
Yes, we can.
Okay, nice. Somehow there is a bit of delay. Let's go back and so now I will start with blockchain use cases. So here you will find that I will just touch upon the key areas in which you can use blockchain. I'll not be going in depth. That is something I will leave to Shyam as I finish this presentation to take you through. So blockchain use cases can be found in multiple areas. To give an example, it can be either in trade clearing and settlement. For example, you are a clearing house and you want to settle. Right now, it is being done by stock exchanges or done by clearing houses that can be decentralized using a blockchain platform. Then you have coupon payments across trading or in any kind of trade finance system. You can use blockchain to record and also help with the automated coupon payments. And then insurance claim processing is another area. Microfinance and microinsurance is another interesting area where you can explore supply chain and trade finance also is a great area where you can use blockchain. An example is where, let's say, you want to save all the what you call the documentation of various stages of in a supply chain or in a trade finance which works across a globe, like in shipping. You can always use them to be verified, digitally signed, and a reference to be present in the blockchain, so that that acts as your point of truth and would help to decrease the counterparty risks that exist in the system and can help improve the trust factor. And then also in case of products, to have a provenance history, again it is like a typical ledger, but it is in a distributed manner, and a lot of use cases are coming in this area as well. And then finally, peer-to-peer transactions. Blockchain or which was created from Bitcoin was itself to create a mode of financial transactions in a peer-to-peer mode, and that too in a secure and also in a semi-anonymous manner. But the same feature can be used across industries to facilitate transactions. And then finally, voting. Voting is a very interesting use case which now more and more people are using. In fact, how a blockchain does a voting for either kind of protocol upgrade or how a fork of chain happens. For example, the latest forks that are happening on Bitcoin is in a way how you can do a decentralized governance, and that is one of the very good use cases where blockchain can be helpful. Then we have use cases of electronic medical records, then providing unified health access, and then you can also do automation using smart contracts. And then finally, public sector. In a public sector, like record keeping, like for example, land records. Now there are certain countries, they have started putting their land records onto public blockchain, which not only helps decrease the transparency factor, but also helps to increase access to those records which were not previously possible. Okay, so these were some of the use cases. Now I will quickly jump into just explaining basics of Ethereum. Now, unlike Bitcoin, which was considered as a financial a financial transaction or financial network, a decentralized network for financial transactions over the internet is envisioned as a platform for creating decentralized applications. So this project was started somewhere around August 2014. It grew to whatever it is today. And I will just quickly explain that unlike a case of Bitcoin, where basically you have nodes that only do transactions or keep the transaction history. In case of Ethereum, you have concept of smart contracts, and these smart contracts run in something called Ethereum virtual machine. Basically, these smart contracts are compiled into EVM bytecode, where these contracts reside across the network in the Ethereum, and are, whenever any kind of request comes for the execution of these smart contracts, these are executed the Ethereum network to verify each of the steps of the transaction. And again, if you remember, I talked about public and private key and wallets in case of Bitcoin. Even in Ethereum, there are wallets and also the concept of accounts. But there is a difference. And the difference is that you have a normal external owned account where you only would have a private key and a public key for verifying your transactions, but you won't be running any kind of smart contracts on them. And then there are contract accounts. These are special accounts to host a smart contract. And whenever any kind of request comes to this particular contract account to run the contract, they execute. And based on the execution, there would be kind of statement that it is executing. It would have some kind of transaction fees. So not only in Ethereum, for transferring any kind of ether across network, you would be spending some transaction fee, but also for executing smart contracts, you will be spending certain ether. And ether is not only the mode of transaction across the network, but also it is the currency which would be used as a transaction fee to be given to miners. I think I have covered a lot as far as Ethereum is concerned. I think we've already covered an earlier session on it. I'll be probably, or I can cover later on a session dedicated on Ethereum. But just to give you an idea about some of the blockchain and Ethereum related terms, first is blockchain. A blockchain is, as we told, a global ledger or a global network where each node contains a ledger of all the transactions that have ever happened, and and each of these transactions are saved in a chain of blocks, and these blocks are what are present of node. Now, in the context of Ethereum, we have a concept called Ethereum virtual machine. Ethereum virtual machine is what that helps to execute any kind of transaction. Sorry to say, Ethereum smart contracts, which are nothing but a code for any kind of decentralized application that would be running in a safe provided by Ethereum virtual machine. And these are run in a Turing complete language, which at a higher level can be coded using Solidity, Serpent, and few other languages. Node is their server, or you can say which saves a blockchain network would have. There would be 2 to 3 types of node. In case of Bitcoin or Ethereum, one is the mining node, and then there is the non-mining node. which are basically either used to save the transactions in the network and get access the services of Ethereum, or to poll the transaction sent to other nodes. And nodes are called as the mining nodes. They are primarily used for verifying a transaction, unconfirmed transaction based on doing some cryptographic operation, or Ethereum running each of those code in the Ethereum, in the smart contract, each of the code that is present in the smart contract code, and then verifying them if it is valid or not. And if it is not valid, it would reject that. And if it is valid, it would definitely add it to the block and then circulate it across all the nodes across the network. Proof of work. Proof of work is the way in which the consensus is achieved. So a miner has to execute certain complicated mathematical and and through this execution, once it is verified, they add it to the block. Now, the Bitcoin, it is Merkle tree. Ethereum is running a particular in the EVM for smart contract and verifying if it is valid or not. So now to understand the concept of cryptocurrencies in case of public, a cryptocurrency is basically used for two purposes. One, it can be used for doing a transaction between A to person B, that is your transfer. It's like a currency. Also the currency to pay the transaction fees. Those are paid to either miners or verifiers who add it to the transaction network. A difference would be, for example, new, where there is a separate currency for verifying the transaction. Okay, so you have concept is called gas in case of Ethereum. About a method of calculating how much cost it would be, how much transaction cost you would need specific transaction or operation on the Ethereum network. A similar concept also exists in Bitcoin, where using which your total transaction cost for any kind of Bitcoin transaction is calculated. And finally, coming to dApps. Basically, dApps in itself can take a full session, but at a high level for newcomers, the idea is to create a decentralized application. A decentralized application is nothing but a UI which provides a usable interface to users, which talks to the smart contracts. The smart contracts reside the blockchain network and are run within probably some kind of storage mechanism. Again, this storage mechanism can be distributed or decentralized. Example can be IPFS, Ethereum Swarm API. And then once is done, API is exposed by that blockchain platform, verify what has been credited, transaction have happened. Okay, so I'll just take a quick break and just verify if everything is fine and everyone can hear me. Okay.
Yeah, the audio is much better now.
Right.
Yes, I can hear you.
I just I would anyway.
Yeah, I think the issue is caused because you are trying to stream the YouTube and at the same time trying to present. I think that's why the issue was caused.
Okay. All right. I'll just go back to I'll try to finish the rest of it. Much more of these slides. I know a lot of. Just skip all these, and anybody can read them later on. Uh, okay, I'll just touch upon Hyperledger. Okay, Hyperledger is an example of a private blockchain. Hyperledger was envisioned by IBM and another group called Digital helped to create this particular consortium, basically create a product for enterprise, so which is a private blockchain. So a part of the code known as Hyperledger Fabric was open sourced in Feb of 2016 to the public, and that forms one of the core features of Hyperledger project. But by now there are a lot more projects that are being added to the overall Hyperledger ecosystem, and it is much bigger now. But if you see where the Hyperledger Fabric fits in, it provides the base consensus algorithm and also basic set of services through which you can access the core blockchain provided by IBM Fabric. And to add to that, the Digital Assets is the company that actually worked with IBM to provide Hyperledger servers, which are basically for enterprise, through which you can a set of companies or a consortia can host the nodes of Hyperledger and can run the whole blockchain. Last reading, I think it has reached version 1, and more and more projects are added to the whole Hyperledger projects. Okay, so an example Hyperledger like, as we discussed with Ethereum, also in the case of Hyperledger, you have a basic blockchain fabric, which is the basic infrastructure to add blocks and host transactions. Then you have blockchain services. The blockchain services consist of the consensus manager, which provide the consensus mechanism. In case of IBM Fabric, they have something called PBFT, that is, I think, which is a way of Byzantine fault tolerance to prevent the 51% attack. Now, just to give you a high level, in case of a private blockchain, you don't have a concept of miners or proof of stake. So what happens is that you need a manner in which the consensus can be achieved, and PBFT is an algorithm to achieve that. And then you have the distributed ledger, which is basically the same kind of linked list of blocks that I explained earlier, which is saved on each of the nodes, and then a P2P protocol where you can send the transaction and blocks across the network. And then finally, the ledger storage, where the actual ledger is stored. And then you have, in case of IBM's Hyperledger Fabric, you have a concept of chain code, smart contract on Ethereum. So in case of Hyperledger Fabric, it runs within a Docker safe environment, and as of last reading, I remember you can develop it using Golang and probably also in script. And finally, you have a security ledger and an event stream. Event stream is what through which you get notified of any kind of events that happen on the network. And then you have Hyperledger services, which is the final API layer through which you can access the Hyperledger platform. And then since it is a private blockchain, you need to control who can access this network, and that is controlled by the membership services. I would suggest to go to the Hyperledger website and also refer to Hyperledger Fabric to provided on the Bluemix platform for IBM blockchain to get more details about IBM blockchain and how Fabric works. There are other projects as well, but I have kept them for a separate session, and these are out of the scope of the current presentation. Just to give an idea of how an enterprise blockchain would look like, enterprise blockchain would have a network layer, data layer. So these are the traditional network stack which comes up to a transport layer. But then you have to contain a specific session to keep the details about how an access to the blockchain is done. Then you access to the blockchain message exchange, which would be kind of a overlay network to access the blockchain network itself, where you can either submit your transaction or message to the blockchain network, or you can receive any kind of notifications. And then you have the core blockchain service. And I think Hyperledger Fabric provides the upper two layers as explained in my previous slides. Okay, so now there are certain blockchain is still evolving, and it's not that everything is the what do you call blockchain is itself an answer to all the security issues that are there that comes with a centralized system. It has its own positives and also first is its decentralized nature. With decentralized nature, if you are running a public blockchain, anybody can come in and anybody can go off. And there is also risks of a malicious party trying to control the overall network, trying to which is here mentioned to control the 50% of the mining power, and then try to either either act maliciously or either to change the consensus to work in their own format. A good example is the current effort of Segwit2x that was started on a blockchain, but which failed. If the what is happening, folk and create their own blockchain, and this is more how public of smart contracts. Smart contracts are still evolving, still stable. And when you are running either interacting with a blockchain network, you are running a smart. Always do a security audit to check their infrastructure connected with, verify your smart contracts. An example of one such issue that happened with Ethereum smart contract, autonomous organization, which contained a lot of funds, vulnerability, all that investor money was stolen, and then they had to fork the network to recover a part of the funds. So this comes to the security holes, but I would rather leave the other slides for you to view. But for me, the future, if you see for block, the reason being, you have a lot of innovations coming into the blockchain. You have concepts like smart contracts, which as they are evolving, will help us to decrease the trust factor that we have to now depend on central organizations, and would help to automate using smart contracts to automate some of these operations that currently are done manually. And then you have concept of decentralized applications. So you would no more need a server to run a particular application. Rather, you would have a network where you can host your application, and anybody across the network can access that. It has a benefit that your application is not attacked by someone. And if somebody has to attack your application, they have to attack the network, which decreases the risk of your application going down. And then finally, the concept is decentralized autonomous organizations. This is a vision which is being implemented by many ICOs and many projects in the Ethereum and blockchain community, where they want to run the complete organization on a blockchain platform, where the decentralized governance and also voting and identity, everything would be managed on the blockchain, and which is a very exciting, which has a very exciting future, and a lot of very interesting work is being done here. Now, I would just directly pass on to Sham, just a minute. Let me just if anything is there. Okay.
Yes, I can hear you. Yeah.
Yes. I'm stopping the presentation now.
Yeah. Yeah, just to do a check. So I hope my voice is clear.
Yes, but there is a little bit of drop in that. So
Okay, so I guess there hasn't been any more concerns in terms of the audio. So I hope the audio is fine now. Right. Yeah. So shall I take over now?
yes, please.
Yeah. Okay. Okay, guys. So sorry for the initial bloopers on the audio side. So I hope we have been able to cover that. So I'll be covering some use cases of blockchain that I have built, or I'm kind of discussing with some prospective clients. But before that, I would like to give you kind of a point of view about how to think about blockchain. So basically, blockchain is wait. Let me just share my screen. So I'll be using a PPT to draw some crude images and shapes, and then I'll be able to explain that to you in a better way. And then I'll jump straight to the use cases. Okay, so I'm just sharing my screen. Just give me a moment. Okay, so I hope my screen is visible to everybody. Dash, can you just confirm that?
You have to, I think, present to everyone. Just see if, because I'm not able to see that.
Present to everyone.
So when you share, there would be option to present to everyone also.
I don't have an option to present to everyone. I just see an option whether to show the entire screen or only an application window, and then I share, and then
You see there another button.
Okay, you're not able to see my screen?
Now I can see your screen.
Okay, great. Yeah, can you see the whiteboard? Yeah, I hope the screen is visible to everybody now. Dash, if you can just confirm that.
Yeah, for me it's visible.
Yeah, okay. Okay, so let's move ahead. So okay, so the thing about blockchain is all about so there are two terms which we always hear in the context of explaining blockchain. So one term that we call one of the most common terms that we use is decentralization. So it's a decentralized system, we call it. And the other thing that we often use is it's a more secured way of doing business or doing transactions. So obviously, I mean, I'm not going to get into the details of how that whole security thing works. I mean, I'm sure most of you who have explored blockchain would understand how this whole security mechanism works, where one block depends on the previous block. So if you alter one block, so all the previous blocks become invalid, and all the crypto stuff about it. I mean, the cryptographic and the ciphering stuff behind that. But I'll just give you a general overview from a different point of view. I call it the different point of view about blockchain, which is about the decentralization of the system. So traditionally, all of us are used to living in a centralized system, right? So you have a central government, you have a central bank, you have a central system, and basically, even for your land registration or any kind of government help, you have a central government or a government department. So the way it works like this is that you have a guy who is basically the central guy, and it's you and it's another party, and you guys are sitting across the table, right? And all your assets, be it land or money or whatever you want, I mean, whichever kind of system you're dealing with, they actually reside with this central guy. And if you want to transfer something, so let's say you are A and the other party is B and the central party is C. And if you want to transfer something from A to B, so you always request the central agency, and basically he transfers that asset to B, and automatically the ledger, he maintains a separate ledger for you and the other party. So in your case, the ledger goes down, and in his case, it goes up because the transfer is happening between you and him, right? So this is how all the centralized system works. Now, in case of blockchain, what happens is you don't have a centralized system, right? So in case of a blockchain, what would happen is all the assets are actually laid out on a table. You can actually consider it like that. And let's say it's you who is A and another party who is B. And let's say another party who is D in this case. I'm not using the C here just to avoid the centralized system. You guys can stake a claim to the respective assets so that it is known across all of you who owns what asset, right? So this forms a trust, a chain of trust, where A says that I own this asset, and it is known to B as well as D. D says I own this asset, which is known to A and B, and B says I own this asset, which is also known to A and D, right? And similarly, if if there's a new party who is coming into the system, and D is doing a transaction with this new guy, some kind of a transaction wherein he's transferring his asset to E, then actually that is maintained in a block. So as more and more transactions happen, more and more blocks get created, and that's what leads to this entire concept of decentralized decentralized ledger, which is shared across all of them. So in a sense, blockchain is a digital equivalent of the oral trust-based system, which you typically find in many parts of the world. So especially if you come from a small town, right? So in a small town, either in India or wherever in the world, people know each other, right? People know each other very well, and people know what each other own. So if I own a piece of land, my neighbors know it, and whenever there's a transaction between the localites, everybody, the entire village or the entire town comes to know, because they are so closely bonded together. But when you move to cities, then that concept is not really possible, because new people are coming in, and as more and more people join the system, in terms of uh, maintaining the land record or whatever it is, the trust becomes difficult to scale. So what essentially blockchain essentially does is that by decentralizing this whole system and maintaining a common ledger which is shared across all, a blockchain enables you to scale the trustworthiness, scale the trust among the people, and that way it is more beneficial for any transactional kind of an application. So any kind of a transactional application where more than two parties are involved and there are multiple resources and assets are involved, and wherever you can quantify the asset with some dimension, you can actually use the blockchain system. So that's how blockchain kind of uh, revolutionizes the traditional centralized based system actually. Just to give you some examples, so this is a small image of what I'm trying to say. So this is something which I just explained. So this is actually some kind of a system where you have got an agency, a centralized system, and you have got certain individuals, and obviously this is the block. And so let me just erase the block part for now. So this is actually a blockchain use case, which is meant to help people who have recently been let out from jail. So they are basically convicts. So in the US, obviously, thanks to the government's initiative around social security and all that, I mean, it is supposed to be mandatory that you are supposed to provide certain basic livelihood and basic necessities to all the people who are coming out of jail. And typically, these things are kind of orchestrated through some agencies, or typically non-profit agencies. So here I'm talking about an agency who is having some kind of a resource. And this resource could be food coupons. It could be some shelter for a monthly on a monthly rental basis, or a monthly basis, community kind of a shelter, or it could be kind of a piece of clothing which the person can wear and something like that. So it could be any kind of a resource. So typically in a blockchain network, what will happen is the agency will own all these resources, and as more and more people sign up to their service, which are the people who have been recently let out from jails, the agency will keep dispersing these resources to these people. And as the agency keep dispersing, the blocks will get created, as you can see here. And obviously the agency's own account of the resource will get depleted, and accordingly it will get transferred to the different individuals. And each block would basically contain the transaction of how much of that resource has been passed on from the agency to the individual, and block by block it will build this decentralized ledger. Over a period of time, this would be a good way for the agency to figure out who is consuming how many resources, whether they're paying it back or not, and based on that, they can also establish the trust or the trustworthiness of the individual. Because obviously, since they are convicts, it's much more important to ascertain whether they would really be trustworthy in the long run or not. So this is one application of blockchain that that I have actually worked on recently for a customer. So let me show you one more application, which is I'm just sharing my screen again. I just unshared it. So one of the most common use cases of blockchain we always come across is the supply chain network. So I just reshared my screen. So Dash, just confirm if you're able to hear me, or if you're able to see my screen rather.
I can see you and also hear you.
Okay. Okay, great. Yeah. So when we talk about, I'm sorry. Is there any concern, Dash?
No, nothing. Please
Oh, okay.
go ahead.
Okay, great. Okay, fine. Yeah. So one of the most common applications of blockchain, we call it in supply chain, right? So in supply chain, you have multi parties, and there's a multi-party transaction which is happening, and goods are getting exchanged in return of some other goods or maybe money. So that's the most ideal way of using blockchain. Now, traditionally, again, you can build a supply chain system using a portal kind of a centralized portal kind of a system. But then obviously it again goes back to the central control. Instead of that, if you can form a consortia of supply chain vendors or the supply chain network, then among themselves they can form a private blockchain, and then all the transactions can be recorded in a decentralized ledger, which will be available to all of them. And that will actually ensure that the trust is maintained, the end-to-end traceability of the transaction is maintained. And there are several other advantages which can be very, very specific to the application that we're building. So one of the applications that you can see on my screen here is a supply chain for agriculture. So where you have a farmer who has a farmland and he is having a farm produce, and then obviously, as you know, in the agricultural supply chain, the distributors play a big role because obviously farmers cannot reach the end consumers so easily. So there is a distribution network over here. And for the sake of simplicity, I've just shown a single warehouse, which is a distribution chain. And then obviously the next step is the retailer, who's the final destination of the farm produce where it is being sold to the retail customers. So you can consider it as a simplified form of agricultural supply chain, which contains a farmer who has a farmland, a distributor who has a warehouse, and a retailer who has a retail store. Right. So in this case, I have a small video which I'll just play, and it's available on YouTube also. So I'll just play that. So basically, what is happening is first, the farmer will sell his produce to the warehouse, which is the distributor, which is which is talking in the warehouse, right? So initially, everything is kind of empty because there is no transaction happening. But then we will allocate some assets to both the farmer and the warehouse and the retail store. So this is built using a blockchain, private blockchain library called multi-chain, as some of you might be aware of, using the Python version of the multi-chain. So this is what you're seeing in the video right now, right? So basically, I am initializing 3 nodes of blockchain network in this case, which is the agricultural supply chain network. So one node is the farmer who is having the farmland. Second one is the distributor who is having the warehouse, and third one is the retailer who is having the retail store. So the first step is to allocate the assets. So I have allocated 1,000, let's say, kgs of some crop to the farmer. And I have also allocated some money. I mean, this could be again a Bitcoin or some kind of an altcoin, but for the sake of simplicity, let's assume it's in dollars. And for the retail store also, I have allocated some money. So it's like the crop will be exchanged against money and so on and so forth. So this is like the initial asset which these 3 nodes have in this entire blockchain network. So the first step in this supply chain is that farmer is selling his goods to the distributor. So he's initializing exchange. So in the multi-chain parlance, we always say that we initialize an exchange and then we complete the exchange. Right? So the farmer is distributing the goods to the warehouse, and when it reaches the warehouse, the distributor accepts that. Right? So farmer offers 20 kgs of I'm sorry, I think I just missed it. Let's just see that. Yeah, so it offers 20 kgs of the crop to the warehouse, and against that he gets $20. So if you can see now, the ledger on the farmland and the warehouse has been updated. The crop was earlier 1,000 kgs, but now it has become 980, and it has become 20 kgs for the I'm sorry, it's slightly hidden here. So for the farmer it becomes 980 and he gets $20 in return. So basically he sells $1 per kg, and the warehouse guy also accepts that. But then he had $100,000 earlier, but then since he bought the crop, he has $980 right now. The one thing that we did here is the 20 kgs that was transferred to the warehouse was transformed into a packaged product, because finally it has to go to the retail store. So that's why it is no longer shown as 20 kgs of the crop in the warehouse ledger, but that the warehouse ledger is actually updated with yet another transaction, where we are saying that we are converting that crop into 5 kg packets. So that's why it becomes a quantity of 4, right, at the distributor side. So now what the distributor will do is that he has to sell it to the retail store. So he will go ahead and do one more transaction with the retailer. So as part of that, he will transfer these 5 kg packets, right, the 4 packets, and he will ask for $200, which is like $50 per packet. So the retailer will initiate the transfer, and he will get those 4 packets. And now retailer is only having $800. So retailer also started with $1,000, but since he bought those 4 packets at $50 each, he ended up spending $200, and his balance amount is $800. So this is how the entire transaction has happened. And at the end of this transaction, you would have this ledger, which will get created across this decentralized system, which where all these 3 nodes are participatory nodes, where the entire transaction from the farmland to the warehouse all the way till the retail store is actually captured. So this is a way. This is actually the why this system has been developed is that in many parts of the world, and especially in India, as we all know, farmers are really exploited, right? So they never get the real value for their money, because since they are in villages, they don't know how much cost or how much price they can command in cities. And distributors, they have their own network and they play nexus, and obviously they try to siphon off the maximum amount of profit from selling it to the retail stores in metros and big cities. If you have this kind of a consortium based application which is based on trust, then what happens is farmer also gets to know what are the profits and the margins being made at each step or each leg of the whole system. And hence, if you have a consortium led system like this, you can actually roll back some of the profits which are being earned by retailers or the distributors back to the farmer as well. So this entire process can be tracked, and if you govern it in the right way, then you can actually benefit all the parties involved in the system. So this is how the trust is built and established and maintained, and it is also scaled. And this is something which you can only achieve using blockchain. So in a centralized system, you would not be able to achieve that, because there would be one central party who would be controlling everything, and he may not even allow the farmers to see uh, the subsequent transactions that happened for the crop that he had sold. Right. So likewise, there are many such applications where a tri-party or a multi-party transactions are required, and if they are done in a trustworthy way, then it can actually benefit the suppliers or even the consumers, right? So in a way, blockchain is that way. That's why blockchain is being considered as a future of the I mean, it's a key driver for the future industries actually, wherein you can envisage everything being done in a decentralized way, which is much more trust based, and obviously the trust can also scale to millions and millions of nodes as more and more people join that particular network. So this is how blockchain can actually play a role, and I hope I was able to kind of give you a decent enough explanation of how blockchain can actually help you in your own respective use cases and in your own industries. Right. So if you'd like to discuss some use case specific to your industry or your domain, then probably you can ping me later on, and then probably you can have a offline discussion based on that. Now I'll give the floor back to Dash, and Dash, it's all over to you.
Thank you very much for this wonderful explanation. First of blockchain and how the decentralization is achieved using blockchain, and then giving demo of how blockchain can be used in our real life apart from cryptocurrencies. Today, I thought when are the best use cases for blockchain. But after seeing your demo, I can very well say that used in various and is that we have to be imaginative and we have to consider the true capabilities and limitations of blockchain. Thank you very much for the explanation, Sham. And then right now I'm just opening up the session for questions. Quickly go through the questions that are there in the live feed, that is the live chat. And if you have later on, I will be adding in the same uh, from the in the same video. If you later on, when you and come back, you can watch the recorded session, and also be added to the relevant use cases and blogs and PPTs that we have shared here, and also how you can reach us help. Okay, so I have a question from Amit Kulkarni, who has asked, how about the reporting in blockchain after transaction interface or application? Yeah, just to answer your question, called Block Explorer. Just a minute, let me just open a sample Block Explorer for you to show. Okay, I think my network speed is less. The overall screen to show you example of a public blockchain network where you can see all the transactions that are happening on the blockchain. That are being, let me just present to everyone. Okay. There are every blockchain would provide you with a block explorer, and these block explorers are basically ways in which you can see transactions that are happening. Please view it traditionally a transaction hash, and from where it came from and to where it is going. Traditional transaction fees. This is with respect to public blockchain. In case of private blockchain, also similar, but there may not be, say, value part. Would be the hash or the has been passed in case of every transaction. Okay, is there any further question to ask? Pinging. Like for those who like the use cases. Yes, just a question on will it later? Yes, it would be available later to watch. You can always go back to the same URL, watch this particular session, and all the required link reference to the speakers today. Parting words. Maybe have your final words. We can say goodbye to all. Further questions?
So yeah, thanks everybody for joining in, and I hope you like the use cases. I think that would help you to kind of rekindle your mind and start imagining some of your traditional applications that could be, re-architected using blockchain. So look forward to hear some thoughts from you guys on that. So you can check out some of the resources that I have presented. So Dash will be sharing with you, and you can reach out to us through email or
Okay.
comments. Yeah, so I'm done. Thanks, Dash, and
Yeah.
thanks everybody for joining
I
in.
Yeah, and just final words, Amit. I would in the meetup here. I will be sharing the details. You can directly ask your questions about this farmer and farmer to retail use case. Uh, just to tell you, you can actually create your own block explorer. You have to develop the UI, and it can show all the transaction as it goes, or in a manner. So all these are present, they are exposed through APIs. You have to create the UI. uh, I think more questions can be or more discussion can be done on this platform. I'll just share the WhatsApp link where you can go and join and continue with this discussion.
Yeah, I think if any one of you is in Bangalore, then probably we can have an offline meetup also, because we having these meetups on blockchain. So you guys can, you're most welcome to join some of our subsequent meetups, which will be announced.
Yeah, and even we will be doing subsequent videos. So I'm just sharing probably the group link, WhatsApp group link as well, just in case anybody comes in, they have further questions they can ask there, uh, and also the meetup page where they can comment the questions later on. Sham, and please subscribe to this channel. There will be more such videos and more such interesting conversations that would be happening, and we would like more and more people to enable themselves and also share more knowledge about blockchain, cryptocurrencies, and the whole ecosystem. Thank you very much. Thanks, Sham. So
Yeah,
I'm
thanks,
signing
guys.
off now.
Yeah, thank you. Bye bye.
Bye bye.